Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'm gonna talk about the PySpark DataFrames and schema. In our previous videos, we have talked about the RDDs, right? Now we're gonna talk about the DataFrame, right? What is DataFrame? Let's get started. DataFrame is nothing but a distributed collection of data organized into a named columns. It is similar to a table in a relational database or a pandas data frame. So simple thing is, it is equivalent to the SQL table, okay, basic table, which we have the rows and columns, but only difference is the data will be distributed collection of data now, okay. It is the same concept. You can just simply think data frame as a regular table which is used to store data in a structured way. Only difference is it's a distributed collection of data organized into a named columns. All right. So what is schema? Again, the schema word is again coming from the basic DBMS. Schema meaning is structure. Over there we say schema meaning is structure of a table. Now we say structure of a data frame, which include column names and the data types. Over there we used to have a simple command available, describe table name, right? Here we have a print schema, okay, which we'll see today. So these are the commands through which we can get to know the structure of a data frame, okay. It's a schema, means structure. So why schema matters? Okay, now in the RDD we never talk about the schema, right? But here we talk about the schema. So why schema matters? First, it enforces the data consistency. It also help optimize the execution plan. So having the schema, it's good for us because it ensure the data consistency. The data remain consistent all the time. Second thing is it help us in optimizing the execution plan. So whatever the plan we have thought of, we have to optimize. It can help us in optimizing those plans. So now we have two mechanisms available. I'll be showing you with the practical today as well. One way is inferred schema, second is manually defined schema. Inferred schema meaning is that Spark will automatically recognize the schema. Means Spark guesses the data types by scanning the data. It's called inferred schema. Okay, it means we don't have to bother about, because everything will be done by Spark itself. But in this case, we have to define explicitly the column names and data types. That's why it's called manually defined schema. We can use the infer schema option to go with the inferred schema, and we can use StructType and StructField option for manually defined schema. We'll see today in a practical as well. So we have two ways available. Either let the Spark decide or let the Spark guess the data type. One other way is we have to define the data type of our own. So what are the common sources in PySpark? Means common data sources in PySpark through which we can create data frame. We can do it using CSV file, very commonly used format, comma separated using data exchange. Second, JSON file, okay, JavaScript object notation, which is used for storing hierarchical or structured data. Third one can be a Parquet format, which is a columnar storage. It's efficient for big data. So we will be seeing today how we can read those files, or how we can create a data frame out of these files, right? So let's get started. So now I'm already having my PowerShell opened up and my PySpark opened up. So let's start with the very basic little thing first, okay, how we can create data frame, okay. First of all, the very first method I'll be using, it will be by using the RDD as a base. Because we in a previous video I've talked about RDD, so we have a mechanism available through which we can convert the RDD into a data frame. So let's do that first. We know how to create RDD, so I'll be using basic method of parallelize, okay, to create one RDD in front of you. And in this case I'll be defining simple data. I'm having a tuple kind of a data available. Let's suppose I'm having ABC comma 30, okay, the first entry. In the same way I'm having second entry as well, which is nothing but the XYZ, and then we having a 25, okay. These are the two entries I'm having. All right, done. So I've just passed the list of tuples here, okay. So I'll be using now, okay, what I'll be doing, I'll be now using one method called toDF. toDF means converting to a data frame, okay. We are now going for unstructured to structured using toDF. In the toDF we can specify the column names here, okay, named columns. So first can be first column will be a name column, and second will be a age column, okay. There will be two columns available, okay. So let's see whether it's working or not, because I want to display the results also. For displaying the results we can use RDD, the whatever the name, dot show method. Okay, we can use dot show method to do that. Okay, so let's see, RDD1 dot show. So show is equivalent to collect of RDD. Collect was used to print the results. In the same way we use show in a data frame. So show is used to print the data frame. Okay, it's like a select star from table name of SQL. Okay, you can see we got answer, right? So we got answer in a proper structured format, the rows and columns. This is the first type. Second one is we can do it with the help of reading a CSV file. Okay, let's read a basic CSV file, and so we can create a data frame. So for that I'm already having one CSV in front of me. The very basic CSV I'm using, this one, data.csv, in which I'm having only the three rows available, name and age, right, just to keep the thing simple. So let's read it. So df underscore csv, this is gonna be my data frame name, equal to Spark, which is a Spark session dot read dot option. Okay, Spark dot read dot option, in which I'm using first option as header comma true. Header true meaning is I just want to keep the first row in a CSV file as my column name. So header true, and then I'm using dot csv. In a dot csv I'm just giving the data, the path, complete path where my file is available. It is available in my D drive csv. Okay, so this is the simple syntax I'm having. Okay, one thing I missed here, I'm also using here infer schema, which I already told you. Infer schema meaning is let the Spark decide what's my data type by scanning the data. So infer schema equal to true. This is I'm also using. All right, done. So very basic syntax available. Spark dot read dot option, header true meaning is I want to keep first row as my column name, and this is infer schema true meaning is let the Spark decide what's my data type. Okay, how we can print, I've already told you. We can print with the help of show method. So you can see it's working fine, right? And we can also print the schema as well with the help of print schema. You can see print schema, right? We got a column name, data type, everything. Nullable true meaning is it can handle, it can allow we can entertain the null values. Okay, next one is we can also use another method available. It's nothing but the create data frame method. Okay, let's do it. Again I'm gonna create one simple data equal to again a very basic data I'll be keeping with me, again in the form of tuples abc comma 30. Okay, first tuple. Second one I'm gonna have xyz, okay, 34, something like that. Okay, this is done. Okay, this is done. Data is ready. We can also define columns, names equal to again name and again age. Okay, this is I'm doing it so that I can use create data frame method. So let's do it. df equal to, we can use here Spark, which is a Spark session dot create data frame, D capital, data frame, F capital, and let's pass the arguments. Arguments are nothing but a data comma columns that we already defined in the previous lines. Data dot columns, comma columns, right? Let's do it. df dot show, and you can see you'll be getting a result here. This is another method available. So we have used now three methods. One using toDF, second is by reading a CSV file, third method is using a create data frame method. In a create data frame method we have defined our data and we have defined our columns. So we are using create data frame in which we are passing the data and columns, and we are going to print the results with the show method. So we have used the command df dot show. So you can see we got our results here, right? So that's it. Next, moving further, now we can also have the simple JSON file also. I'm already having JSON file with me. I'll be now reading or creating a data frame out of JSON file. You can see a simple JSON file available in which we have again two columns, name and age only. So how we can read that JSON file to get my data frame out of it? So I'm having df underscore JSON as my name of my data frame equal to Spark dot read dot JSON. Okay, and in this case simply give the path of that JSON file, D drive, right? It is data, sorry, the name of the file is, I guess, sample.json. Yes, sample.json. It is in my D drive, sample.json. That's it. And how we can print? We know it is df_json, and you can see we got a results printed. So it means now we have used 4 methods so far. Next method is we can also use the Parquet method. So what is Parquet method? I'm already having my data available in a Parquet format. Okay, this is it's unreadable format, right? You can't see it. I've already generated this format of my own. So again, it's have a same data, this one, the age and all. Okay, so I'm just gonna read the data, gonna read it, and gonna create data frame out of it. Although it's not readable, but let's read it and let's create data frame out of it. So I'm again using a same syntax. Okay, very simple. Instead of JSON, write Parquet. Okay, and right here the complete people.parquet. Okay, and I'm just changing name also, df_parquet. So we are done. So let's print it, and you will see it will be a data in a proper structured format. You can see we got answer, right? So it's another method available. So I hope all the methods are clear. So last point before we end up this video, I just want to show you how we can manually define the schema. Okay, the manual one, because we have used the inferred schema option, but let's do it manually also. For that, we have to import some packages from PySpark, PySpark.SQL.types space import StructType. Okay, we're gonna use, I'll be explaining what is StructType, comma StructField, okay, comma we're gonna use integer type also, integer type, and last one we're gonna use is string type. Okay, this we have imported. So what is this StructType? StructType is a container for whole schema. Inside that StructType, we're gonna use StructField to define my columns. Okay, it will be more clear when I do it here. Schema, I'm gonna define my schema manually with the help of StructType. So StructType is a container for whole schema. Inside that StructType, we're gonna define my StructField. Okay, because I'm gonna have 2 fields, so I have to use 2 fields. One is name, one is age. So StructField, okay, field F capital, StructField, in which we have to define the name of the field, which is name, comma string type. The first one is gonna be a string type, okay, which is the name. Okay, string type, and third one is nullable true. We have already seen that in the print schema option, it will be nullable, whether we want to allow my data frame to allow the null values or not. It's nullable true, so it is nullable true. Okay, and the same way we can now define the second as well. So second one, again same way, StructField, okay, this time around it will be age, okay, second field name, comma it will be now integer type, and last one true again. Okay, true again. Let's press enter. Schema is ready. Now let's create that data frame out of it. So I'm gonna name it as manual equal to spark.read.schema. Okay, schema will be my schema which I've already made, schema. Okay, and dot csv, the same csv which we have already used earlier, d drive data dot csv. Okay, and we can specify header equal to true. Done. Let's now print it, and we are done for this. Manual dot show, right? So I hope you must have understood today's video, in which I have explained what is data frame, what are its benefits, right? It's a structured format, and we have seen how we can create data frame. We have seen all the options, one from CSV, one from JSON, one from Parquet, one from RDD. We have seen create data frame method toDF method, manually defining it, getting it inferred, right, by the Spark, right? I hope everything is okay. So we'll see you next video. Thanks for watching, guys.